Okay, you have learned how to solve all different types of equations. We learned how to solve linear equations. We've learned how to solve quadratic equations, rational equations. Now what we're going to be focusing on here in section 9.7 is how to solve radical equations. And when we solve radical equations, we're going to use these 4 steps. Step 1, you want to isolate the radical. We want to get the radical all by itself. Step 2, we will look to eliminate the radical. Step 3, we will solve for the variable. And step 4 is an important step, one that students tend to overlook and forget about, but it is an important one. You want to check for extraneous solutions in the original equation. Now, we encountered extraneous solutions once before, you may recall, in chapter 8 when we were dealing with rational equations. Well, they're back again. Remember, extraneous solutions are ones that don't work in the original equation. So that's going to be an important step here, step 4. After you solve for the variable, take whatever that number was that you got, substitute it back in, plug it back into the original equation, and make sure it makes sense. If it doesn't work in the original equation, then it's an extraneous solution. Let's start with an example. Let's say we have the square root of maybe x minus 2 plus 5 is going to equal, let's say, the number 8. So we start with step 1. Step 1 requires us to isolate the radical. So I'm going to have to subtract 5 from both sides. And that would now give us the square root of x minus 2 equaling 3. Okay, now we move on to step 2. We want to eliminate the square root. Now remember, because it is a square root, what we're going to have to do is I'm going to square both sides. Notice how I put parentheses around them. Very important. Whenever you square a square root, okay, as long as the exponent and root index are the same, they will cancel each other out, leaving you with just the radicand. So because I squared the square root, we're going to be left with now just x minus 2, equaling, on the right side now, 3 squared, 9. So now step 2 is done. We have successfully eliminated the radical. Now we have a simple linear equation to solve. To solve this linear equation, we would have to add the 2 over, in which case now we get x equals 11. But I'm not going to circle this just yet because I want to make sure that this solution is not extraneous. So the way to do that is to go back to the original equation and check my solution. So I'm going to check that the square root of x, which remember is now 11 minus 2, if I add 5 to that, it's supposed to equal the number 8. Let's see if it does. Well, the square root of 11 minus 2 would be the square root of 9 plus 5. Does that equal 8? Well, the square root of 9 is 3 plus 5. Does that equal 8? Well, since 3 plus 5 is 8, and 8 does equal 8, that does check. So now I with confidence can circle my solution of 11. Okay? Let's try another one. Very similar to the first one, okay? Where we will go through the 4 steps. In our second example, let's take now the square root of maybe x plus 5 plus 6 more equals the number 4. So, step 1, we have to isolate this square root of x minus 5, x plus 5. So I will subtract the 6 over. That would now give us the square root of x plus 5 equaling, on the right side, a negative 2. Okay. Now, So that I have successfully isolated the radical. Now I'm going to move on to step 2. I want to eliminate this radical. So to eliminate this square root, once again, what I'm going to do is square both sides. And because I am squaring the square root, that will leave me with just the radicand of x plus 5 equaling, here on the right side, if I take a negative 2 and square it, that would give us a positive 4. Well, step 2 is now done. Let's move on to step 3. Once again, we have a nice, simple linear equation, and to get x alone, I would subtract the 5 over. And that would give us a solution of x equals a negative 1. Okay. Once again, though, before I circle this as my solution, I want to check it. So I'm going to go back to my original equation, and I want to see that if I take the square root of negative 1 plus 5, and if I add 6 to it, does that in fact equal the 4? Well, let's take a look and see. The square root of negative 1 plus 5 is the square root of 4. Plus 6, does that equal 4? Well, the square root of 4 is 2. Plus 6, does that equal 4? Well, here on the left side, 2 plus 4 is 8. Well, as we can see here, does 8 equal 4? That's nonsense. 8 does not equal 4. So that means that the solution that we got of negative 1 is not wrong, okay? It is just an extraneous solution. It's an extra solution. It does not work for the original equation, okay? It works perfectly fine for this linear equation, but we weren't asking to solve the linear equation. We wanted to solve this radical equation. And since negative 1, our only solution, is extraneous, that's when we would say no solution. So in the first example, we got one solution and it worked. In the second example, we also got one solution, however, it did not work. And I'm going to give you a little hint, okay? I was able to tell earlier on that I knew that the answer was going to be no solution. I was able to tell right at my first step, right over here, okay? Whenever you have the square root of any algebraic expression, and if it happens to equal a negative number, okay, whenever this happens, whenever you are taking the square root, and if it happens to equal a negative number like it did here, okay, right up here is where I knew it was going to be a no solution, because I'm taking the square root of the algebraic expression x plus 5, and the fact that it equals a negative number, the negative 2, whenever this happens, right away, you don't have to figure out anything. It'll always be a no solution scenario, okay? So that'll save you some time on tests, okay? Now, in the first two examples, we had just one radical as well as one variable. Let's see what happens now in our next example when we have more than one variable. For example, the square root of 2x plus 1 is going to equal the same variable x. So now we're dealing with a second variable. We're still going to go through the same process, the same 4 steps. So in step 1, we have to isolate the radical. I'm going to subtract the 1 over, and that would give us now the square root of 2x plus 1 equaling x minus 1. So step 1 is done. Step 2, now we have to eliminate the square root. So whenever we want to eliminate a square root, we have to square both sides. And notice the parentheses. I put a parenthesis around the radical that I squared, but then I also put a parenthesis around the x minus 1, and I have to square the right side as well. Now the left side's not so bad, because whenever you square a square root, you will always get the radicand, 2x plus 1. The right side, there's a little trick here. You've learned about this. A x minus 1, a binomial being squared, means you want to write it twice, as well as you want to, in fact, FOIL it. Okay? So x minus 1 squared, we write it twice and we FOIL. And if we FOIL it correctly, you would get x squared minus 2x plus 1. So now what did we form? We went from what was originally a radical equation to now what we have here, which is a quadratic equation. And in order for us to solve, you may recall, from chapter 7, to solve a quadratic equation, we have to get one side of the equation equal to 0. So I'm going to subtract 2x over, as well as I'm going to subtract 1 over. And that would now give me an x squared minus 4x equaling 0. And now that we have the quadratic equation equaling 0, recall, how do we solve quadratics? Well, it's been a while, but we have to do a little factoring now. And so what we could do is we can factor out the greatest common factor of x. And if I take an x out of the first term, we're left with x. If I take an x out of the second term, the negative 4x, we get a minus 4. That's the factored form. And so now that zero product property would tell us to set each factor equal to 0. So I'm going to set x minus 4 equal to 0, and I'm going to set x equal to 0. Well, there's nothing to solve here, but let's solve over here for x. I'm going to add the 4 over, in which case now we get x equals 4. So now we have two solutions, okay? We had two variables, therefore now we're going to have two solutions that we have to perform a check. We want to check now both solutions. Let's start with checking x equals 4. I'm going to take the number 4, and remember, we have to plug it back into the original equation. So I need 2 times 4 plus 1 more plus 1. That is supposed to equal my x value, which is 4. So let's see what happens now. We're going to take now the square root. 2 times 4 is 8, plus 1 more is 9. Plus 1, that's supposed to equal 4. Well, the square root of 9 is 3 plus 1. Does that equal 4? Well, 3 plus 1 is 4, and since 4 does equal 4, that checks out. So there is one solution. Now let's go and check our second solution, that x equaled 0. So let's go and take the square root, the original equation, 2 times 0 plus 1 plus 1 more is supposed to equal our x value, 0. And so now, simplifying the square root, 2 times 0 is 0, plus 1 is 1. Plus 1 is 0. When we take the square root of 1, we get 1 plus 1. Does that equal 0? On the left side, we have 1 plus 1, or 2. Does that equal 0? Well, 2 equaling 0, that's nonsense. Okay? 2 does not equal 0. So therefore, 0 was actually an extraneous solution once again. So even though we got two solutions to our quadratic equation, only one of them worked in the original radical equation. So don't give me 0 as a solution, only give me the values that actually work. Okay. So the first problem and the second problem involved just one radical and one variable. The third example involved one radical but two variables. Let's see what happens with a slightly bit more complicated problem when we not only have two variables, but we also have two radicals. For example, the square root of x plus 5 plus the square root of x is supposed to equal the number 5. Now we're still going to go through the same 4 steps. So step 1, you have to isolate a radical. Don't jump to step 2 and try to eliminate the radicals. That is the common mistake. The very first step that you must perform is even though you have 2 radicals, you must isolate one of them. And it don't make a difference which radical you isolate. You get to choose. I'm going to isolate the first one. Okay, so I am going to subtract the square root of x over. Okay, now this is where it's going to get a little bit more complicated, but definitely doable. So here, on the left side, we have the square root of x plus 5 is going to equal now, on the right side, 5 minus the square root of x. Okay, so just like in the previous problem, okay, when we were left with a square root equaling a binomial and we had to square both sides, okay, I had to do a little foiling. Well, the same is going to be true here, okay, because I have to eliminate now this square root, this radical that I just isolated. Now I want to eliminate it. So I'm going to put up my parentheses, and I'm going to square the left side, and then I'm going to put up a parenthesis, and I'm going to square the right side. And now, once again, here on the left, it's not so bad, because when we square a square root, we're left with just the radicand, x plus 5. It's the right side that's a bit more involved now, because I have this binomial being squared. And whenever we have a binomial squared, it is recommended that you write it twice, and then that you actually perform the foiling, because that's what we're going to have to do. So let's see what we get. If I multiply 5 times 5, we get 25. If I multiply the 5 with the square root of x, that would give us a minus 5 square root of x. Well, now I have to multiply the negative square root of x with the 5. That would give me another negative 5 square root of x. And then when I multiply a negative square root of x times another negative square root of x, we get plus x. So when I combine my like terms here, I am left with a 25, a minus 10 square root of x, plus x. So we have successfully performed step 1. Now let's go and continue. We actually performed step 2 as well, because we isolated the one radical. The problem is that there's a radical still in the equation. So it's at this point I have to go back to step 1. And when I go back to step 1, I now have to isolate this second radical. So I am going to subtract 25 from both sides. And I'm also going to subtract x on both sides. Here on my left side, I am left with a negative 20 equals. On the right side, I'm left with a negative 10 square root of x. Now, if I want to, and I probably will here, I will divide both sides by the negative 10. On the left side, we will have the whole number 2. And on the right side now, the negative square root of 10 divided by the negative square root of 10 leaves me with simply the square root of x. So now we have isolated that second radical, okay? So now I have to perform step 2. I want to now eliminate this radical, so I am going to square both sides. On the left, if I take 2 and square it, we get 4. If I take now the right side, if I square the square root of x, we get simply x. But remember, I'm not going to circle this just yet because I want to check into the original. And so now we're going to take the square root of x plus 5, that would be 4 plus 5, plus the square root of x, that's the square root of 4. That is supposed to equal the number 5. Well, let's see if this is true. Under the radical, we have the square root of 4 plus 5, which is the square root of 9, plus the square root of 4. Does that equal 5? Well, the square root of 9, that's 3. And the square root of 4 is 2. And 3 plus 2 does equal 5. So since 5 does equal 5, that checks. We got our one solution. Okay. I'd hate to think we did all that work and got a no solution. That would be a lot of work for nothing. All right, so that was a more challenging problem because we saw here the nature of the problems where we had to perform step 1 and step 2 twice. Let's do another one together. You know what? I'm going to give you one to try on your own. Okay. And here's the problem. The square root of 5x plus 6 minus the square root of 4x plus 1 equals the number 1. Once again, we are dealing with 2 variables and 2 radicals. So pause the video here and try this problem on your own. Once you have completed the problem, click the video back on and see how you made out. Well, hopefully you got 2 solutions, okay? And both of them actually work. Let's see what those 2 solutions might actually be. I'm going to begin with step 1. I'm going to isolate a radical. Does it make a difference which radical you isolate? I'm going to pick this first one, and I'm going to get it by itself. I want to add the square root of 4x plus 1 over to the other side. And in doing so, we now have the square root of 5x plus 6 equaling 1 plus the square root of 4x plus 1. So step 1 is done. I have isolated my first radical. Now I have to eliminate this radical that I just isolated. So once again, I'm going to square both sides. When I square the left side, not so bad. We get just a 5x plus 6. But when we square the right side, it's a bit more complicated, okay? Because you have to write it twice, 1 plus the square root of 4x plus 1, and then 1 plus the square root of 4x plus 1. And then we have to FOIL this. And if you FOIL correctly, what you are going to get is a 1 plus 2 square root of 4x plus 1 plus 4x plus 1. Okay? We can combine the like terms that we have here on the right side. So I'm still going to have the 5x plus 6. And on the right side, I have the 1 and the 1. That would be a 2 plus 2 square root of 4x plus 1 plus 4x. So we have performed step 1 and step 2. However, there is still a radical. Okay, so we have to now go back to step 1 again, and we have to isolate this radical. And so I'm going to subtract the 2 over. and I'm going to subtract the 4x over. On my left side, I have an x plus 4 equaling a 2 square root of 4x plus 1. Now we have isolated the radical. Now I'm going to have to do step 2 again. I have to eliminate this radical. So once again, watch the parentheses. I'm going to square the left side, and I'm going to square the right side. When I square the x plus 4, once again, you're going to have to FOIL that. And if you FOIL x plus 4 when you square it, you're going to get an x squared plus 8x plus 16. And when you square the right side, you have to square the 2, which gives me a 4. And you also have to square the square root, which would give me a 4x plus 1. So now we have successfully eliminated that second radical. We still formed a quadratic. So now let's solve for the variable. I'll distribute my 4. X squared plus 8x plus 16 is on the left. On the right side, we have a 16x plus 4. Because it's a quadratic, I have to get one side equal to 0. So I'm going to subtract the 16x over, as well as subtract the 4 over. And that would give us now x squared minus 7x plus 12 equals 0. Well, once again, that skill of factoring has come back to haunt us. So let's factor this down. X and x, different signs, and the factors of 12 that add up to 7 could only be a 3 and a 4. By setting each of these equal to 0, we would get x equals 3 and x equals 4. Oh, I made a mistake. Up here I said 8 minus 16 is a negative 7. My apologies. It's a negative 8. And that's going to change these factors here. The factors of 12 that would add up to the negative 8 would have to be a negative 6 and negative 2. Okay, which would mean x equals 6 and x equals 2. Okay, now let's go and check to make sure these work. Going back to the original equation, if we plug in 6, if we take the square root of 5 times 6 plus 6 more, and then subtract the square root of 4 times 6 plus 1 more, does that equal the number 1? Well, let's see. Under the first radical, 5 times 6 is 30, plus 6 more is 36, minus. Under the second radical, 4 times 6 is 24, plus 1 is 25. Since the square root of 36 is 6, and the square root of 25 is 5, 6 minus 5 does equal 1, so it does check out. So there is one solution. Let's check out our second solution. Square root of 5 times 2 plus 6 minus the square root of 4 times 2 plus 1. Does that equal the number 1? Well, 5 times 2 is 10, plus 6 more would give us the square root of 16. And then 4 times 2 is 8, plus 1 more is the square root of 9. Square root of 16 is 4. Square root of 9 is 3. And since 4 minus 3 is 1, 1 does equal 1. So we have found two solutions. Okay, that is a very good problem. It has a lot of skills, Okay, not only the new material of solving radical equations, but it has a lot of old skills built into the problem. You have to be comfortable with foiling radicals, foiling a binomial. Of course, the skill of factoring to solve a quadratic. Okay, this is an excellent problem, one that you should know. Okay, not that the other ones are any less important, but this last problem is a very good problem. Just saying. Hope you enjoyed it, and I'll see you on the next lesson. Don't forget that there is homework that goes along with this section 9.7. Try the problems, okay? Take your time with them, and if you have questions, shoot me an email. Hope all is well.